sort of an overview on how to balance chemical reactions and how to find precipitates. And it also will help you during the Module 10 lab with the chemical reactions, where you will have to write a full, complete chemical reaction, balanced as well, for all the precipitates that you see. I have chosen one example from that lab, and I will walk you step by step on how to do it, and then you can work on the rest just the same exact way. So if we are mixing calcium chloride with sodium carbonate, what will be the result? You will get a precipitate. So let's try to figure out what that precipitate will be. First of all, it is important that you know the charges on the polyatomic ions, such as the carbonate here, CO3, that you know the charges on the rest of the ions that aren't polyatomic ions, monatomic ions, such as the calcium or the chloride or the sodium. So review those rules, and then you will also need to know the solubility rules. So if you mix two types of ions, which ones are still going to be soluble in water and which ones are considered insoluble. So refer to the table in your book. Okay, so when we put calcium chloride in water, and these are all aqueous solutions, the calcium and the chloride are going to split apart into separate ions. And I have only one calcium ion, so I only get one. You see there's no number in front of the calcium here. We don't write it because it's one and it's implied. But this 2 down here as a subscript tells me that there are 2 chloride ions. And so when this molecule splits apart, that 2 that is written as a subscript for the chlorine in the molecule comes in front of the ion, like so. So I have 2 Cl-. If you notice, chlorine is a group 7 ion, and so chlorine always has a -1 charge. We don't write the 1, we just write the minus. It's implied that it's a -1. Calcium is a group 2 element, and it always has a +2 sign, +2 ion. So if I look at calcium chloride, I have calcium with a 2+. To balance it out, because an ionic compound such as calcium chloride is a neutral compound, and so to balance it out, I need the total positive charges to be equal to the total negative charges. The total positive charge is 2+. The total negative charge is -2 because I have 2 chlorines with a -1 each. So 2 times a -1 gives me a total of -2. -2 plus 2 gives me 0. So calcium chloride is a neutral compound. So now I have 1 calcium, 2+, and 2 Cl- in solution. Now let's look at sodium carbonate. If I get this molecule and I put it in water, it will also dissociate into its separate ions. Once again, just like with the chloride, this 2 belongs to the sodium, so I have 2 sodiums, and each sodium, because it's a group 1 element, has a +1 charge, so I have a total of 2 plus 2 for the positive charge. CO3, now this is a polyatomic ion, and you can't separate the carbon from the oxygen. They're bound together as a unit, so this whole CO3 has an overall of 2- charge. So I have +2 from both sodiums and a 2- from the CO3, giving me a 0 overall charge for sodium carbonate. In solution, however, they split apart, so I have 2 sodium pluses and a CO3 2 minus. Okay, so these are the 4 types of ions that I will have in solution once I mix these two. Now, what's going to happen if I mix them together? Remember that you always, always, always pair positive ions with negative ions. You do not pair 2 positive ions together or 2 negative ions together. So, I could have 4 different combinations. I could have calcium 2 plus bind with the chlorine Cl minus, so I have a positive ion and a negative ion. I have a positive ion and a negative ion. Well, what's that going to give me? That's if I mix Ca, so the calcium with a chlorine, I get calcium chloride. If I mix sodium with a carbonate, I get sodium carbonate, which is my starting material right here. That's not what I need. So I could get that, or I could mix the other 2 ions. So I could mix the calcium, which is a positive ion, with a carbonate, the negative ion over here, the other negative ion, and the chlorine with the sodium. Remember, the positive ion is always written first. So what happens when I do that? Well, I get this. I get calcium carbonate, and because calcium is a 2 plus charge and the carbonate has a 2 minus charge, I don't need to mess with subscripts here because my overall charge is already 0. 2 minus plus a 2 plus gives me a 0 charge. So I have calcium carbonate, and then I could also mix these two together, sodium and chloride, to give me NaCl. However, sodium chloride is soluble in water, so it's not going to want to form a precipitate. You are still going to just have sodium and chloride in solution as free ions. Calcium carbonate, if you look in your solubility rules table, you'll find that it's insoluble, meaning it doesn't dissociate into ions. So when calcium ions find carbonate ions in solution, they bind together forming calcium carbonate, which is really lime, and it falls out of solution as a white precipitate. So that's why I have a solid here, S for solid, to indicate that it's a precipitate. All of these ions could have an AQ for aqueous as a subscript here. I just did not want to put a lot of information here for you to get confused, but you could put it in parentheses as a subscript as AQ for aqueous. And that is how you go about doing these types of, how to balance these types of reactions and how to find. The most important thing to remember is that you will have a neutral compound forming. So your positive charges have to be equal to the negative charges. Treat all the polyatomic ions as if they're one unit, as if they're a single ion, not made up of multiple types. Put them in parentheses if you have to, and if you have to have more than one. So if I needed to have 2 CO3 ions, carbonate ions, I would have to put parentheses around the CO3 and then put a 2 as a subscript. So don't let that 3 confuse you over here. If you put parentheses around it and use it, think of it as one unit, as if this whole CO3 were, let's say, a chlorine, then you can treat it like any other ion by using the subscripts to manipulate how many you would have to use. All right, and that is all.